just okay. Hi everyone. So for today's talk, I think what we have done in last two talks and sessions, right? We spoke on Scala, we spoke on Spark. We try to understand how Spark works with the Scala, and we figured out that what are the internals are important to understand for Spark and Scala. And as you know, everyone, that with Spark you can build data warehouse, data mart, and enterprise data platforms. So the today's session is all about how performance-wise you can read the data more optimized approach way, and then you can process. So I hope the title given was chain data capture. So in brief, let's understand that what does it mean and how you can pull the data with CDC approach way. So let me just find out a couple of resources here. So generally, when you try to read the data from any source, let's say if you are trying to read data from SQL Server or any table, you will scan entire table. You won't be, since let's say any other JDBC drive or any other program that you use, you will try to read the entire table. So you scan entire table to read some of the data. But in general, when you scan entire data and when you process all the data, you pay the penalty of processing all the data. So let's say, given the scenario, if you want to build the ETL system, you want to only read a couple of chain data which happen at the source side. So think like you have a source table, those are SQL Server, and you want to write back to MongoDB. That is a target for you. In between, you want to read the data, you want to flatten the data, means denormalize data structure, create your own data model such as star schema or the factor schema, and then you want to do aggregation, processing, and everything. And ultimately, the target is your process data. Those are high-level KPIs. Aggregation happen on the source data, right? So in that case, ultimately, you are processing all the data for your project. Think like the source is SQL Server, that is the product. So that product is used by all enterprise customer for you. So everything that they do becomes one transaction, insert, update, or delete, and persist in a SQL Server, right? So now that is a source of data for you, what customers are doing. But obviously, being a CXO, you are not worried about all transactions happening at the SQL Server. What is your important thing is that you want to know that what customers are doing and those KPIs, sales, return, and the purchase, and the taxation part, and your revenue part. That's, for example, is important for you. So to compute that, you will have predefined formula that you will go ahead and then you will compute that data based on your computation formula. Now, you compute in all data, let's say, regardless what recently change happened at the transactions. That's where you read all the data. Now, CDC means what? Chain data capture. You capture only those data which has only changed at source side, right? So every RDBMS has some utility to figure it out, chain data capture. So what is important? Because if you pull all data, if you process all data, then you pay much more compute time, and you pay also compute cost. Your servers, your cluster, your infrastructure, your cloud, everything gives you high amount of cost to process the data. So let me share my screen and show you some of the fundamental techniques to process the data with CDC way, right? Now, when you want to process the data with CDC way, there are a couple of different approach. One approach is that you can use in CDC itself logs, right? There's something called transaction log. So every database system has backup and utility, restore utility. For that, RDBMS stores some transaction logs. log system in the transaction, and that transaction logs are available without affecting query on top of the production data. Now, if you have the production data where you get all the data inserted and transactions being inserted and persisted, now if you think to query that data, then you will have performance impact on the product itself, right? Because when you query at that time, let's say if you are trying to query, at the same time your production users and customers are doing transaction, so there would be some latency, there would be some interruption, there would be some deadlock, there would be some side effect, there would be some and other process delay and process what do you call it, connection timeout, and those issues might occur over there. To avoid that overhead, okay, what you do is that you read log transaction logs, and transaction logs are high level logs without impact to the production real data. So you can read that. Second thing, to do CDC, you might have the column. That column is called time-based column. So you go to your target and figure it out, last inserted maximum date or time. Based on that, you go to source and filter only those records in the query which are above that, right? Create time or update time. You can create own tables in the source system, and you say that get date and time from the database system level. So you don't have to insert. When any insert update happen to specific row, at that time you can have that column being updated. The second thing. Third thing is that you can have own trigger. In SQL Server, you can create the trigger and say, when insert, update, and delete happen, give me that ID and insert those IDs to the specific different table, custom type of way, right? That you can create own custom. Now, what we are talking is just CDC, chain data capture. We are not talking the kind of benefit or the functionality given by SQL Server. In generic, we are talking if you want to do CDC on any RDBMS, how you can do that, right? Third thing is that you can create a versioning of the column. Okay, so first versioning, second versioning, third versioning, and at the end you pick the last version, maximum version of the record. Now this is supported by default by HBase. In Apache HBase, you can have a versioning of the rows, and then you can pick that, right? And so this is what I think we have spoken so far and discussed, that log reader, query, and trigger. Impact on the production is low, high, and minimum, which you can see here, right? Other thing what you can do is that you can have own custom city and then have this programmatically trigger last option, that you can capture the data and preferred method, no access to transaction logs in case if you don't have, right? I think, yep. Second thing, once we're done with that, so in this discussion and this session, we will take example of SQL Server and talk about some of the built-in capability of SQL Server to do CDC and CT. So you understand that how it can be done, and then we'll talk about other products, how you can do that.
Chetan, in this case, the query is not suggestible to use.
Pardon?
A query.
Your question is to query what?
Yeah, the query is not preferable to use in using the CDC technique.
If you're talking
Based
about
on some date column.
Yeah, so still when you query the date column, you are touching on real production records, right? Scanning that. So
okay.
So let's say in target last maximum date and update date was something, right? Now generally when you scan the table, you are scanning the table and scanning the create time update time. Now you get based on create time update time, but I don't think you will get deleted records from that, because you only get insert and update, right? And then you can get those data and go ahead, but still you are touching and scanning the you still need to establish connection on production tables, right?
Right. Okay. Entire data to be scanned, that means you're saying that is a problem.
Yeah, I mean, you technically query plan will have the predicate that to which predicate the condition you are applying where close, right? And maximum to this. So the paging in the Balance tree
Yeah,
will
yeah.
get adjust accordingly, but still you need to have a connection on the production schema, right?
Right, right.
I mean, this is one scenario. Let's say if you have 200 and 300 tables, and if you invoke 300 connection to production, that will have impact, right? So I think we are not talking about low level latency, but we're talking about entire enterprise level solution which can help, right? So let me share my screen. We'll talk about SQL Server gives something called chain data capture capability. So how it works, and we'll go to the second approach and what is the difference between this approach and that approach. We'll talk. So chain data capture with the CDC allows you to capture, insert, update, and delete activities that is applied on a table in SQL Server, right? And then those details will be changed, would be available in relational format to you. So this is not something you get abstract unstructured data that you need to marshal and then you format that to some predefined structure. But SQL Server gives you an RDBMS format where you can just query the data. Now, column information and the metadata that is required to apply these changes in a target environment that would be captured in terms of modified row and stored in chained table with the those change with the structure of the same source table. So the structure of the source table will be directly copied as same structure for your track changes, and table valid function that you have that which you can access the chain data that will be also available in that. So CDC will create predefined table for you where they will maintain the metadata of the CDC, and there would be predefined table valid function or store procedure that help you to access those tables. For example, this can be used for an ETL systematically loads chain data incrementally to data warehouse or the data mart. So this is a given example by them only. If you have OLTP, okay, online transaction processing system, that's what we spoke earlier, that if you have transactions, how you can handle those. Now this source table, which you can see here, will be populated with OLTP. Now there will be transaction logs, as we said here, and there's a capture process given by CDC SQL Server. This will capture and write back to chain tables. So how this will work, you have predefined table, let's say invoice table. Now you will get invoice underscore CT table, where this capture process will write chain tables over there. And then you have chain data capture query functions, which help you to pull the data from chain table. And then you can do ETL here and write back to data warehouse. I mean, we are talking high level concepts. We are not going in well detail, so everybody understand in this group. Now, if you want to do that, what you can do, you have to enable the CDC on database first, and then you need to enable the CDC on the table first. Right now, this maintains the transaction logs and different data, metadata. So your temp DB or your physical disk will have impact in SQL Server. It will grow a bit. So you need to adjust the size of physical disk and temp DB before you proceed further with CDC. So you can use the store procedure called cp underscore CDC enable DB. That will help you to enable the database with the CDC. Same with the enable table will enable the CDC on table. Now metadata of captured instances which you have with store procedure, if you want to get those chain data capture, you can use this CDC help chain data capture store procedure that will help you to pull the data from CDC change metadata. Now, what does it contain? This contains three tables inside that: chain tables, index columns, and captured columns, right? Naming conventions for CT tables would be default table name underscore CT. For the functions, if you have, let's say if you have a function called function name, you will get fn underscore CDC underscore get all changes for that function, and then you will be able to capture those changes in the function, right? So far good. Now you might have a concern. What if I have a views in the source system? What should I do? Then what you can do, you can have a shadow copy of the clone of transaction system, and you get all these CDC tables here, and create the same definition of view on top of CT tables. So then what happened, that view is created, and when you invoke the view, you get the result set of the same view given all these CT table changes, right? So when you query the views, you only get chain data given the fact of all changes happen to the CT or CDC right now. Now, how internally it maintains the data for the chain table and commit log sequence number. Every log will have commit log sequence number. They call it LSN, and then the column called operation records the operation that is associated with that change. 1 is equal to delete, 2 is equal to insert, 3 is equal to update before the change, and 4 is equal to update after change that you do, right? Because you will have change in update. The previous value before update and the value after update. And the data which you have deposited in chain table will grow potentially. So you don't actually, you need to clean up that also, right? So let's say this is a cleanup process. So how you can clean up retention-based cleanup policy that they have. So SQL Server supports that. So chain data capture cleanup process, it moves the low endpoint, the validity interval to satisfy the time restriction you have. By default, it will store data for 3 days. And if you have retention policy, you can define by yourself. You can create the process in SQL Server, which can start invoking this process, and then it could be triggered automatically the way you want. It also maintains the maximum versioning and minimum versioning. And if your query doesn't fall between minimum and maximum version, then it will fail. So you need to make sure that minimum version and maximum version is what you really want. Now you can maintain own logging framework where you can, every time you have one workflow, you will say, what was last time maximum version for this? You store that. So second time when you invoke your entire workflow of ETL, you just query that column, get the value, and compare with minimum and maximum version, and pull the data. Now, once you get this transaction logs, you also need to know schema evolution. Schema evolution means the change happens at the column structure. So what CDC supports, that we will talk. The capture process extract the chain data from transaction logs. There's a built-in latency between the time is committed to source table and the time that the changes appear, that you need to understand that. Because I mean, once you have the transactions, and there is something called SQL Server agent that will pull those changes and write back to transaction logs periodically. That latency is what latency you will get, but that is no time actually, and very small latency, so you should be fine with that. If you want to recruit, same thing which we spoke, these are the functions which help you basically get CDC, get minimum LSN and get maximum versioning. And if your query falls in out of this thing, then your query will fail. So you need to make sure that you maintain that. So the real chain history, think like you have a table, you have 5 columns, and someone dropped the column 5th. So what will happen? So the real history, chain history, will always supply null value for that. But if you have the column and if you change the data type for that column, then this will be taken care in sp underscore cdc underscore get underscore the real history. So in both instances, capture logic requires SQL Server agent to be running for the process to execute this both store procedure. Now, apart from that, you have also one table, one store procedure by the real events that affected track tables by using this store procedure. So let's say you have entries happening in the log, actual transaction logs. Now you want to capture those transaction log history, that what happened, when happened, those things. That data would be captured in sp underscore cdc dot underscore get real history. You can pull from the history transactions and see what happened where. In case if you want to have custom implementation, in case of data failure, in case of deadlock, anything you want to roll back thing, how you can do that. So these are the tables are important to understand that what you can do with those things. This was high level on CDC. Now there's second concept called CT, called chain tracking. I have made large document on that. I will share that with you after this call. But high level, let me explain before going to detail that what is the difference between CDC and CT. CT is lower level version of the CDC. And these are 2 points important for us. So CT, called chain tracking, is a lightweight version of SQL Server called CDC. It gives you the capability to track changes in the schema and table. So this will give you primary keys for delete, update, and insert. And you can query that by I, U, and D flag. And each table is enabled with chain tracking, same way we did with the CDC. And that is associated on disk table, which has been used by CT. Function to determine the change version and rows has been changed since that version. So you also get the minimum and maximum valid version in CT, and same way you can implement that thing. The major difference is that CDC has a larger impact on compared to you pull all the data, very low impact. But when you compare only CDC mechanism, there is a bit more impact on production and transaction logs, because it has to uh, enable many other processes inside SQL Server, which get you to pull whether the stored procedure that you have many other things to implement that, and then maintain the disk IO and the overhead on TempDB. But CT is lighter version, right? If you want to try this CT CDC mechanism on top of the production system, I think better you go with CT first. If you see positive feedback from CT, you can go with the SQL Server CDC. Now CT will give you only primary keys. Now again, you need to go back to production tables and pull the data for those primary keys. So you need to have a established connection with the production. But in CDC, you will not have that connection established with SQL Server at the end. So any questions so far with CT and CDC with respect to SQL Server? Okay, so then we'll jump back to other design architecture uh, approach with the CDC. So there are solutions in market with the enterprise which you can use to build CDC based application. In CDC, actually, you don't process all the data, but you process the heartbeat of the system, right? So every system has a heartbeat happening like a human body. So what is important for you is today's heartbeat. What was heartbeat for yesterday, probably you will not care because you have recorded heartbeat for yesterday. But heartbeat in a system like SQL Server or any RDBMS, you will capture for today, right? Because that's important for you. So there are enterprise tools like Attunity by Qlik, which has a product called CDC. They call it Attunity Replicate and Attunity Compose. So Attunity Replicate and Attunity Compose will help you to bring the data from source system, but they use internally same mechanism, right? Everyone falls under 3 category, which you can see here in CDC capture method. So Attunity falls under first category called log reader, but you don't have to have own implementation that we spoke like SQL Server to have the query, use the stored procedure, and query that and maintain your own framework, right? Now, if you use the Attunity, it will directly give you the data actual rows. That this is the table calls ABC underscore CT. These are the entire record got changed. So you can just use JDBC and pull records as it is, without having any condition, any check, anything that you do. So how the design works and the architecture works, that we will talk here. So Attunity Replicate and the Compose are 2 products that the project has, and it can pull the data from anywhere: SAP, RDBMS, data warehouse, files, mainframe, and cloud too. It can run on-premise, it can run on the cloud. You can ingest the data with create and update because you would have two things: create, update, and delete. Those are the transaction chains and schema evaluation for thing. And it will give you the row delta here. Row delta will looks like, that this column has changed with this thing and that kind of manner, right? Let me show you how it looks. So this looks like the screen, if you can see my screen. So let's say this is the landing zone where you have the customer ID, company name, contact title, address, city, region, postal code, country, phone, and fax. Two records are here, right? Now, someone had done delete on top of that. So these are the log on the header underscore timestamp. This timestamp, there was an update on customer ID this, and company name this, and contact name this, address this, Berlin this, postal code, country this. After the update, what happened? The record looks like this, right? And again, there was a before merge, the record looks like this. It tells you. And there was a delete this customer, and then new insert was there on new customer ID. New ID, there was new customer insert, right? And there was update on this. So like, it's not only one transaction happen on one customer ID, right? Probably you will have 10 20 transactions on same update ID per day when you have your scheduler invoked. So these are the transaction logs which you can see in landing zone. Now if I ask you to use Java or any other programming language to tell me the latest record, then it will have, you have to scan this, you have to figure out last thing. Again, you can't do much on timestamp because some updates are happening on same timestamp. What you will do? And it's the same problem on the same timestamp happening if your timestamp is this format, not microsecond and those things, right? And then you have to marshal and create, if there was a two update, on which column update was there, pick that, and there was delete, then what column has delete on which value. And you need to have own mechanism to get come up with a kind of derivation and tell the latest record value, right? That is all done by a product called Activity Replicate. Now Compose is a product which will give you in this way, that this was latest for you. So it computes and tell you the latest for you, right? So you don't have to worry about anything else. You just pick the record called first record, which you can see in this screen, and delete the record from your target and write back freshly. Okay, you are done with that. Those records have been changed, for example. So that was part of Activity Replicate and Activity Compose. And the advantage with Compose is that it can work with Hive. Hive is kind of Apache Hive is transaction manager. So on HDFS, it is immutable HDFS on Hadoop. So you cannot delete and update the records in HDFS. Now, that does mean atomic transactions are not supported there, right? If you want to have atomic transaction there, you need to use something called Hive or the HBase. Other thing is that I think this disk which you can see in my arrow is HDFS. If you want to scan some value in between, you can't do that. HDFS supports only sequential access to the data, okay, where Hive and HBase supports random access to the data. Anywhere at any location you can access the data. So Hive being supportive to transactions, you can maintain data warehouse where you get these transactions available from CTC replicate and synchronously update your data in Hive automatically with scheduler. So your Hive becomes your enterprise data warehouse and process data warehouse from where you can pull the data. So technically it does standardize merge format in between that, right? Provision, it will give enrich and update values and give you the data in provision fashion. Now, historical data source and operational data source are snapshot. When you say snapshot, means it is copy directly with the snapshot, and ODS is incremental. If you use the processed Hive, which is transaction manager, right? And then you can connect with any BI tool, Power BI, Tableau, and QLeak, and anything that you have, Looker and whatnot, right? And you can analyze, you can prepare, cleanse, and join here. Again, after that or here only, you need to prepare your KPIs, aggregation, and everything that you want to do. Now, aggregation and join that you do, probably earlier you were doing on full data, but after you have this mechanism, you can do on chain data only. Those records are being changed. This is another way to explain the same architecture. So in transfer, you can have in-memory transfer, file channels. You can do filter, transform at the activity level. You can say, I want to have a filter by this column, by this hard-coded value. I want to have basic transformation there. It supports SQL query, actually. You can edit and then change the query yourself, and then you can process the data in Hive, right? You can process back to Hadoop, HDFS, any RDBMS system. You can actually process this to Kafka topic, which is streaming-based application, right? And you can write back to files. So any source to any source, in between you can do CDC, right? And between you can have intermediate persistent store if you want to have for large data set, right? So yeah, you can build database, data warehouse, data lake, and streaming application and platform with CDC, and that can be replicated, that can do ETL, that can do ingestion, that can do publishing to any other application. Now, the production table and non-production transaction logs. Let's say you have, in one example, you have this production tables, we have non-production transaction logs, and you apply activity replicate here, and it does continuous update and store the data to call ODS store. That is what I mean by earlier ODS, right? What is ODS? And this is kind of short-term basis, right, to support operational reporting, and after that you can transform to your data warehouse. Now, when we talk earlier, whatever we have spoken was on-prem. Now let's talk about cloud, how you can have cloud. One example with AWS, those people are aware with AWS. You can have on-prem data, you apply the CDC, you go to the replicate. Now you can use RDS also if you want to have database service. And then you can connect to queuing system like Kinesis or Kafka. Then you ingest that your queuing system to DynamoDB. And then you have microservices hub on RDS top of that. And then you invoke streams with DynamoDB. And you can have consumers for those stream system, which you can see here. So CDC is not limited to big data or your operation system, but you can actually hybrid and combine with any other architecture. So talk about Spark and Kafka, coming back to our big data system. Let's say you have different replication of SQL Server. One is SQL Server in Boston, other in Oracle San Francisco, MySQL in Dallas, and DB2 in GNU, right? So then you can have on-premise Eternity replicate and can pull from the connection string all the data in replicate and give you the chain data. And then you can just map the chain data streams to the Kafka JSON messages. And Spark can read the Kafka topic and JSONs, as we have spoken in second talk. And then you can have SD Insight or SQL Data Warehouse or internal external subscriber, which can pull the data from the Spark and write back to the Azure cloud. This is for Azure, for example. You can just, Azure has services like SQL Server Data Warehouse, subscribers, Event Hub, and SD Insight. And now question is that, can we connect this CDC with enterprise tools like SAP and Oracle Cloud and PeopleSoft and those, legacy proprietary tools? And can we, because your data can lie anywhere, right? SAP, PeopleSoft, can Salesforce. So can we use Activity? Yes, you can use, because they are a connector and pull the data. So you can do log-based CDC, right? Transaction log-based CDC, and again post back to Kafka JSON messages. Now, if you want to have the data and data lake like HBase Hive or HDFS, you can just write back to HBase Hive and HDFS. HBase you can use if you want random access. Hive you can use if you want random access plus transaction management, and that data is that data can be queried SQL language. So you can use SQL to query the data in Hive, but in HBase you need to use SQL, Hive, HBase query language, and to have some HBase shell to pull data, or write Scala or Java program to pull data. You can't do select star from table. You can do with the tool called drill on top of HBase, but then it sucks in terms of performance, right? HDFS, yeah, you can write to Parquet, Avro, ORC, any format that you want. Spark, yeah, Spark can directly read the Kafka JSON messages from the topic. So coming back to very, very high level architecture now, at the broad enterprise level architecture, coming back from the very ground level understanding and concept that we have just discussed. Um, Given the use case, if you have clinical system and clinical system replication, two systems of clinical, I mean, two SQL Server, let's say two replication factor. One thing, remember, when I use the word called replication, in Hadoop and Spark, replication means the copy. By default, replication factor in Hadoop and Spark, Hadoop and HDFS is 3. Means the same data is copied 3 places. Why? Because if you have disaster recovery or the data lost, you can Spark or sorry, Hadoop can recover automatically from those replication factor without interruption of any service. But when you talk about the replication, to the SQL Server, that does mean that incremental log CP replicate, right? So log-based ADC means transaction logs and pull data with the incremental way. So that you pull Opportunity replicate will do log-based ADC and write to Kafka topic. Now here you can have real-time streaming and base historical data, because you might have some topics in Kafka can have historical change and some topic in Kafka where you have real-time change. So you have to connect here Spark streaming, here you can connect Spark batches to Kafka topic, and then you can mix up Lemon architecture way and write back as a streaming back to structured analysis, graph analysis, and NLP and machine learning you want to do on top of that. So you can really combine CDC at broader level, not at the only database level. I think that's all with Opportunity replicate. So any question so far?
Hi Chetan, this side Saurabh. As
Hi,
you were saying
Saurabh.
that, hi, as you were saying that we can implement CDC on the broader level with the Kafka and Spark streaming as well. So
True,
is there
true.
any chance that we can discuss on this part a bit in a broader way sometime later?
Yeah, definitely. I can have second session to. I mean, what you want to understand is this part CDC to Kafka or Kafka
Yes,
to Spark.
CDC to Kafka.
Yeah, so
Actually,
CDC to
actually
Kafka with
Kafka.
Opportunity, I think you just need to provide the Kafka broker, means the
Mm-hmm,
IP address and the port number, something 9292, which is default, and provide the IP address. Since Opportunity is a product from Qlik, it does for you. Now, if you're talking about that how we can do that without purchasing Opportunity as a product, right?
mm-hmm. Okay.
Then you need to write Kafka producer. So you will go to your Java or Scala. Let's go to Scala program.
Color. Okay.
Yes, Scala will pull the transaction logs, right, from Opportunity
Mm-hmm.
that you have, and then once you have got the batch of the changes that you have, so now you know that you have redefined your structure as I explained earlier in the data set.
Mm-hmm.
Uh, let's go to this one, this example. Now, from this transaction log, you came up with this format, right, programmatically with your
Okay.
JSON.
Mm-hmm.
Once you produce this model in the Scala, you will write this as one event in Kafka consumer. I'm
Okay.
sorry, Kafka producer.
Producer.
So Kafka will produce that event as in any other topic. So now the consumer, it has to just pull the data, right, from that
Right
topic.
thing. Right.
And then if this topic is alive, Spark can pull directly from the same topic, right?
Mm-hmm. So
So that's
basically,
a
just to
nutshell of this concept. Yeah, yeah.
okay. So basically, simple integration for the CDC to Kafka will do the trick, right? I mean,
Absolutely.
yeah. Okay.
Yeah. So then now what is the challenge for you is to maintain the offset in Kafka topic, that which
Mm,
offset you pull, and just make sure that offset order is correct, right?
right.
You can use partition in Kafka and track the timestamp based offset um, from the events. And once you
Mm-hmm.
pulled in Spark, I think Spark maintains the order for you, and then you can process that.
Got it.
Now, Now you get two level of versioning. One, you get header timestamp provided by any attunity. If you don't have such thing, then you
Mm-hmm.
need to introduce timestamp when you ingest that. So now there will be two things: ingestion level timestamp and the
Mm-hmm.
consumption level timestamp. Right? If orders are not maintained. Now it is
Right.
again based on your use case whether order affects or no. If orders are not affected, only primary key is the value for you, then you don't care eventually, because you get the primary key as a singleton to value, and then you just insert to your data lake or data warehouse or whatever you have as a target system, right?
Mm-hmm.
Does that answer your question?
Yes, absolutely, Chetan. Got that
Thanks.
part. Thank you. Thank you very much.
Yeah. I mean, feel free to ask any other question also, everyone. I don't know how many people are there in the call, but ask the question. I think we have 15 minutes to talk anything abstract in this session. I'm done with what information I wanted to present. I just kept 15 minutes for abstract discussion, that if you want to have any other open question, we can spend time and utilize this time for answering those questions. You can ask me anything, like how you can start, what are the primitive things, and what you can read. Anything you can ask. I mean, this is not generic.
Chetan, is it okay if I can ask edge-based questions?
You can ask anything. When I say anything,
Yeah.
just anything.
Okay. So basically, I believe that you have already worked with MSA client.
Yeah, yeah.
There are a couple of your codes I can see here in the repositories.
Okay, good.
So basically, what I was looking into is the library that has been used in the to connect the HBase to Spark.
Yeah, yeah.
Uh, something is there.
Yeah, we use the package from GitHub, Nerdemar, Nerd.
Nademaria,
Yeah, I
Nademar
think this was
library.
4 years ago, but I still remember the package name.
But looks like this Nademar is the privately owned library. It's not the library that has been offered by Spark, basically.
See, in this open source world, right?
Mhm.
Anything that you talk, let me give that example. Now, how we maintain with the Spark is, can you see my screen, Chrome browser?
Yep.
So everything goes to Spark packages here, org, specifically with Spark, right? Now,
Mm-hmm.
anything which you can see when you say privately owned or publicly owned, there's nothing that concept called privately owned or publicly owned, because Spark itself is open source, Apache 2.0 license, right? What does it mean by Apache 2.0 license? That you can freely change the code and redistribute to anyone without informing the source of the author. As just you have to keep the any code the same licensing. As far as you are not changing the license type, you
Mm-hmm.
should be okay, right? Now I don't know, the
Uh,
HBase
Actually,
connector that we're talking about, not a or something like that.
Nademar IT.
There are many packages in HBase, but the one which we use, GitHub, yeah, this one, right? Nodema, if you can see
Yep.
this package. Now this is Apache 2.0 license, which belongs to the same category the Spark is written. So anything which you can see is proposed by GitHub public library. First thing, yeah, you can access publicly, right? It's not private library. Second thing is license is given here, Apache 2.0. So if you read that, what does it mean? It means that anyone can contribute back and anyone can use it, right? Now, if you go to the author who wrote this library, you can see here that so many people have wrote this library, including me, right here.
Mm-hmm.
So, I mean, this library supports and is openly contributed for people. Anyone can change that, anyone can read that, anyone can use that.
Hmm, got it. So the idea what I was trying to say here is that since it is compatible with the current version of Spark, how can we assure that it will be compatible with the further version of Spark as well? So let's say going forward a couple of more years ahead, and if you get a version of Spark where the content of this library seems to be a bit, um, not working with the Spark,
I
or
think yeah, I think it is more important to understand in that level than understanding that whether this will be compatible with the Spark, I think we have to think in that way, that whether it would have the same performance or there will be performance improvement with this library. One of the limitations with this library is that you can have 22 columns because Scala supports 22 tuples, and this is based on tuple, or you have to create edge map or something like that in Scala, right? Now this library is created with Scala 2.10, right, which is way behind. Right now Scala 2.13 is the minimum version that we use right now. Even Scala is coming 3. Now when Spark is shifting towards, this is what I have hard coded to 2.10. Now if Spark is shifting towards, let's say 3 versions, Spark 3 is coming end of the year, right? Now when Spark 3 is coming end of the year, there will be many changes. This library works with RDD based things, right now. So it gives you RDD, but if you want to work with data set, data structure, if you want to work data frame data structure, how you can do that, and those things here, right? So I think we should look at any alternate library if you want to go with performance optimization approach way for going this. This is way behind probably 2017 when I was working, right? But not as same here. I think last commit is mine only. After my commit, I don't think anyone has done anything to this library, right? So I mean, this is a very old library. We were using it that time because that was time to use this library. But now coming back to the question, Spark 3.0 is coming, what to do? I would recommend that look at other library in Spark 3.0 community and performance way, and what are the benefits that you get. And also you need to think that what are the HBase version this library is supporting. If you have older version, newer version, you can figure it out. I believe there's other library from Hortonworks, HBase connector. Now there's many change in Hortonworks because Hortonworks got acquired by Cloudera, and there's nothing called Hortonworks now. Everything's called Cloudera, right? And yeah, look at this SHC. You can explore this version, and this version seems to be a little more up to date. How you can figure it out, open source version? If you see in this project, last commit is what I have done in December 2017. After that, no one has touched this code. It's been 3 years, right? So no one's maintained this. Nicola works in Red Hat. Nicola works in Red Hat, and he has no time to work on anything else. So we have stopped this working on that. Now, Hortonworks is a big company supported by Cloudera, and they have team, they have investment time and money you can spend time on open source contribution, where I didn't have time to do that thing. So you can probably prefer this library and try working with and compare the performance with this, right? This is last commit on January 2009, January 29, 2020, right? So I hope this is much more mature library than what we have right now, right?
Actually, I tried working with this. This is basically defining the HBase catalog and then try to push the data.
It's not high level. It's not easy. A bit difficult to maintain and understand how things work in between that.
Now,
right?
There is a problem here. The problem is that you cannot pass the null values via Spark code to HBase table if you are using this particular library.
True.
And even the earlier library that we were talking about, that too also having the same issue, that we cannot pass the null values to HBase table. So either you have to convert it to a string, or you may have to drop that particular.
I think the question is that HBase is not being supported to insert null through the client that we have. Otherwise, null you can write back. But generally, we were not writing null value to the HBase as far as I remember. We were just writing either empty string or something like that, right?
No, that's the thing. In the HBase, if we are passing any null values, I mean, let's say if a row contains 10 columns, and out of 10 columns, we have 5 columns which have value and 5 are null. And in the another row, we have 10 columns all filled with the values. So in the HBase, what we'll have for the first row, there will be only 5 columns that will be displayed. However, for the second row, all the 10 columns will be displayed. So basically, one row is being stored separately in the HBase, I believe. So basically, what happens is, if you are trying to pass any null values there, that means we are trying to save a bit of space there in HBase when we try to.
Yeah, that's correct. Null will not allocate the space, but I think you need to calculate the statistics based on that, how much value when you write null is taking and how much value when you write empty string
Blank.
is taking, right?
Mm-hmm.
If it's coming in 5 MB, 6 MB, I probably don't think you have to care about those right now, right? In that way, because I believe you can, when you read, you can handle that here, null value. You can say get or else. So this tuple provides you the method in Scala called get or else, and in else you can pass the null. So regardless, tuple 1 has value, it will give you the same value. If it doesn't have, then it will give you null value there.
Got it.
So
that's the trick that we have already applied, but just wanted to understand the architecture in a broader view, that why not null values, why not it's been supported by the HBase? That's the actual question.
yeah, null value write is supported by HBase, I think, or no?
Via client, it's not supported, that's for sure.
No. Can you do it by HBase shell or no?
Haven't tried yet, but
See, if HBase is not supporting to update the null value, then none of the client will be able to do, because ultimately we also use connector with HBase, right? Apache HBase client. Now see, if you can't do with org.apache.hbase.hbase client, then you have to write own implementation. If this is supporting null value to be inserted or updated, then you need to really look at HBase level internals, that how it works, and HBase catalog, and figure it out that how you can do that. And that is, I think, not with the perspective of HBase user, but if you are own self, yourself is developing HBase as a software, how you can handle those things. This is what you need to probably care for that.
Yeah, got it.
Yeah, but
thank you.
Yeah, you can go to the source code of HBase client and see null is supported in a HBase client or no.
Actually,
If this supports, then you are good. If this doesn't support, then you can't do anything.
actually, the connect. I went to the connector source code, and in there it was not supporting basically the
Yeah, then you
connectors.
can't do anything. Yeah, then you can't do anything. You don't have any choice.
Yeah, that's the thing.
Cool.
Yeah, thank you. Thank you very much for this.
Yeah, welcome. So we have still left 6 minutes. If anyone want to ask any question, please feel free. You can ask anything, learning path to anything. Okay, I think fair enough. We are good. Nila,
Thanks,
over to
Chetan.
you.
I think people can actually reach out to you on Hangouts and can drop your mail also if they need any help.
Absolutely, absolutely.
So if Saurav or anybody else needs any help, they can certainly reach out to you. If you need any help in connecting with Chetan and you're not able to find him on Hangouts or find his mailing ID, please do reach out to me. If you have any particular questions that you would want him to cover in the next session, please do share them with us, and we will try our best that we cover those as well. Yeah.
Sure.
Thank you so much, everyone.
Thanks,
Bye.
everyone.
Thanks, everyone.
Thank you.
Thanks, Chetan.